Okay, pre-cal, we are on notes for 1.5 and we're going to be discussing piecewise defined functions. And you'll hear me call them just piecewise functions in the future because it's just a mouthful to say piecewise defined. Anyway, so it's just a function that we define by two or more equations for different intervals of a domain. What does that mean, Miss Griggs? Well, I'm going to scroll down here and show you your this example I've got circled right here. See, we've got x squared plus 1. That's a quadratic function, but it's restricted. The domain's restricted. It's just x less than 0 and x minus 1 where x is greater than or equal to 0. So you have domain restrictions because you're just looking at part of it. It's a piece of the function. That's why we call it piecewise defined. So we're also going to learn how to evaluate these, as you can see down here, and we're also going to learn to write equations from the graphs, and that will come in other videos. Otherwise, this one would be so long you'd want to kill me. Okay, so the very first thing we're going to talk about is a type of piecewise function known as a step function. And we call it a step because, as the name implies, it looks like little stair steps. So a good example of this is something you should be somewhat familiar with. It is the greatest integer function. And I told you we would talk more about this later, and that later has arrived. And so I'm going to increase this picture here for you so you can see the graph better. So as the name implies, it is a step function. So you'll notice that it looks just like that. I'm not going to draw the whole thing because that's boring. Nobody wants that. Oh, I erased something I did. Story of my life. Okay. Oh, look at this. It's turning out beautifully. Okay, that gives us a pretty good idea. All right, so as we look at the rest of this, I want you to remember that your equation looks like this. It is a function, and it looks like x is in brackets, all right, just like that. So when we're looking at this, let's look at our characteristics. The x-intercepts are occurring from 0 to 1, but I've got parentheses at 1 because I've got an open circle on my graph at 1. This means that from 0 to 1, that where I drew that first little mark, that first mark on the graph, okay, let's look at it. Okay, this one right here, that little segment that I drew. Well, if I draw a segment on the x-axis from 0 to 1, it's going to include 0 and all the little decimals leading up to 1, but not including 1 because there's an open circle there. The y-intercept is just going to be at 0, 0. And now let's talk about the domain. The domain is going to cover all of the x values because even though 1 isn't covered on this little circle, it's covered right up here at the next level. So the domain, your x values, it's going to cover every single one of them. The range, however, does not work that way because remember, the range has to do with our y values. I don't know why I drew that way. The x values, all the positives go this way and all the negatives go that way. So since this steps up and doesn't include all these little values right in here, the range doesn't work quite the same way. So the range does not include all of the values. It just includes the integers. And what are integers, Miss Griggs? Well, they're whole numbers, including your 0 and your negatives. That's what your integers are. So in other words, no fraction values. Okay, my end behavior as x approaches positive infinity, y approaches negative infinity. I'm sorry, positive infinity. And as x approaches negative infinity, y also approaches negative infinity. So this is a discontinuous graph because you have to pick up your pencil to draw it. It is not increasing or decreasing. It's not doing any of that. It does not have odd or even because it doesn't have origin symmetry or y-axis symmetry. I know that it looks like it has origin symmetry, but it doesn't, because if you'll think about the reflection going across here, these open circles in quadrant 1 don't correspond to those same values in the third quadrant. Okay, so how do we evaluate the greatest integer function? Well, it's really easy once you get the hang of it. I know that it looks really confusing, but it's really, really easy. So what I'm going to do, I'm going to increase the size of this so that you can see what I'm doing here. Let me erase these, get rid of that. Okay, so let's look at evaluating these, and I'm going to change my pen color here so you can see it better. All right, so the very first one is I want to evaluate the GIF of -1. So in other words, when x is -1. Well, x is -1 right here. Well, that's that ordered pair. So what's y? It's -1. All right, that was pretty easy. Okay, now what about -1/2? So when x is -1/2. Well, x is -1/2 right here. So drop down to the graph. Y is -1. Awesome. Oh, sad face. So it's -1 when x is -1 right here. And it's also -1 when x is -1/2. I wonder what it is when x is -3/4. What do you think it is? Guess what? It's -1. Since there's a flat line right there, every value, every single value for x between 0 and -1, the y value is -1 because of this line right here. Awesome. You're getting the hang of it, aren't you? I knew it. Okay, so number 3, 1/10. This is +1/10. I want to know what y is when x is +1/10. Okay, well, +1/10 is going to be somewhere right along here. All right, well, we have the line right there where y is 0. So that's my answer. All right, so my number 4 here, x is 1.5, so what's y? I'm going to go up to my graph and go, okay, 1.5, that's going to be right here, so I'm going to go up to my graph right there, so that is going to be y equals +1. Groovy. And then my next one, -3.5. So I'm going to go over 1, 2, 3.5. So that's right here. Drop down. There should be a line right there. Okay, that's going to be -4. Neato. 12.7. Okay. Uh-oh. We have a problem. My graph doesn't go to 12. What am I going to do, kids? What the heck, yo? Guess what? There's a way to do this without looking at the graph every time. Let me show you. If I want to know what y is anytime it's between 0 and 1, it's always going to be 0. If I want to know what y is when x is between 1 and 2, it's always 1. You with me? In other words, whatever the value for x is, it's going to be 1 less than that for the y value. Stay with me. For instance, number 2, -1/2. Well, what is the number right below -1/2? -1. There's your answer. If my answer is 1/10, well, that's between 0 and 1. So what's the whole number right below that? 0. 1.5, what's the whole number right below that? 1. 7.2, I skipped this one. 7.2, what's the number right below that? It's 7. So that would be my answer. -3.5, what's the number right below that one? -4. You got to be careful. Remember, your negatives go the other way. And number 7, 12.7, what's the number right below that? It's 12. Yes, kids, it really is that easy. Enjoy.